Hello to viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about floating wind turbines or farm. So let's dive deep into it. Well, we have to understand what exactly is the problem. The problem is that we need a lot of power. We need unlimited power. We need a lot of power and we need 24/7. Does solar have that kind of oomph? Absolutely. But it has this, one of those issues is that it only works 6 hours a day. So that gets an issue. Now, onshore wind, meaning we have been developing wind farms that are on land, be it USA, be it India, be it whatever else, but they are limited. Now, what are the limiting factors, like which you cannot bypass? The first part is infrastructure. It's like, let's say you build the dam puppy. How are you going to transport it? Now, you may not think too much about it, but here's the deal. When SpaceX was being built, it was a serious issue for them. It's like, how the heck you going to build a rocket? Because again, you may not build everything exactly next to a launch pad. So how the heck you going to transfer it? They had to make their rocket super skinny so it can pass under the road bridges, because there is a law that all bridges has to have at least this much clearance. They had to make sure their structure is small enough that it can clear through it. That applies on the basically wind farm also. Unless you have this hundreds of acre of area where you're going to build farm, then you have to build factory right there. Only then you can build really huge ones, which it's not practical nor viable. So that creates a very serious limitation with infrastructure. On top of that, let's say you solved it even, then you have to deal with geography, meaning sea surface, meaning if you take 100 square kilometer of sea surface, is it smooth? From point of land, it's butter smooth, it's just smooth. But when you're talking about geography on Earth, basically you could have mountain ranges, you could have plateaus, you could have forests, you could have so many things that is introducing what we call turbulence in the air. Even though air was going YOLO speed when it's coming into the basically landfall, and by the time it reaches your wind farm, it would be so dirty, it would have lost significant amount of its energy. So even though wind velocity would be good, because of the turbulent air, turbines may not be able to extract as much energy as they want. And this is geographical limit, meaning you cannot bypass it. You cannot just move a mountain. It's like, A, control C, Himalayas, and control V it somewhere else. That's not possible. So there are certain physical limitations which we cannot bypass. Now, sea has one of these benefits because of the smoothness, relative smoothness of sea. Sea has ludicrously high surface velocity airs, meaning if you go into deep sea, meaning if you let go of the coast for like, let's say 50 kilometers or 100 kilometers, the wind there, it's completely different. It's almost laminar flow, meaning it's flowing in one smooth way. Meaning if you put a turbine there, even though velocity would be the same as it would be on land, it will give you a bit more power, or maybe even a lot more. And grand total in terms of velocity, it has much higher velocities. So velocity is much higher. And then we come to another aspect. How many turbines you can put? Well, N. You can put as much as you want, because fundamentally speaking, there is no surface area limitation. Even when you're talking about India, it has a basically sea border. Now that sea border has a zone. That zone is national boundary, meaning no other country gets to talk about it. Every nation has it. Basically, if a nation is there, it has a sea boundary. There is a certain kilometer where it's like they can do YOLO on it. Nobody gets to talk about it. They will not touch international water. India has more than enough. Basically, if once we start to put it there, we have enough in our national border itself that we do not have to worry about it. Surface area is not a limitation. And if you really, really want to push it, like we can go to Point Nemo and go YOLO. Like we can put insanely large amount of it. So that's why we have a problem that we want to build giant turbines. We just can't on land. We have to go to the sea. That's the issue. So let's do some math. Now, what math we are talking about is this puppy. You're gonna get this equation or some derivations of that, which has D, density of the air. You have D, capital D, which is diameter, basically what is the area, quote unquote. And then you have V, velocity, air speed, and then you have a constant. Constant is fixed, remove that. Density of air, you cannot change it, so remove that. So you have two vectors. Basically, these two knobs you control how much oomph you can extract out of the air. So these two vectors define how much energy you can get out. Like if you have poor extraction, you will have only 4 megawatt. If you have good extraction, you can have as high as you want. So wind velocity has this most profound impact, because this puppy is cubed, meaning if your speed goes up a little bit, the energy that you are extracting goes up exponentially. It's cubed. So a lot. Increase it by 10, 10 cubed, basically 100 times more power. Then you have diameter. Now diameter is basically area. You are describing the area. Now this, again, it does have effect. It has a square effect. So 10 becomes basically 10 into 10, 100. Oh, 1000, velocity would be 1000. I made that mistake. So that's the whole point. It's still square set. So what can you control? Like, think from an engineer's point of view. You can't control the constant, you can't control the density of the air. Velocity, again, that's nature's point of vision, basically where you are on the map. You can't change it too much. But you can change is the turbine blade diameter, basically sweep of this puppy, the rotor diameter basically. And this is the most easily controllable factor. That's why every year our turbine gets bit bigger. They have been going on a growth spurt. Basically, back in the day, if you have ever talked to anyone, it's like, bro, I'm gonna make a turbine. It's gonna be huge. People are like, how huge? You're like, 1 megawatt. People are like, whoa, you're gonna make 1 megawatt wind turbine? Damn. Nowadays, we don't even give a damn about 10 megawatt. And I'm not even joking. That's common now. We have turbines that are 10 megawatt and we don't even give a damn about it. So now we are in 12 to 15 megawatt turbine range, basically big puppies. And here's it, because they are generally in the sea and only in test site, nobody has an idea how huge these are. These are so huge that they make Eiffel Tower look like a brother, basically. It's like, bro. And they're like, the sweep area is so huge. You take a football field, put it in there, you still have empty space. The sweep area is ginormous, huge. Like, we have no context of it, how stupendously huge we are making it. And China recently just went bonkers and they are like 15 megawatts. And they are claiming they are working on 20, which again, I will believe them, because again, if you are a country and if you are smart enough, you're gonna pour money into this like there is no tomorrow. And again, brick by brick, day by day, our like, I was so impressed by Halide X turbine. It had like, how many megawatts Halide X had? It does not have the clear rating. It was like somewhere around 14 megawatts. So that was like, whoa, now we have 15 megawatts. Somebody is like 16. Somebody is like 20. I'm pretty sure in next 10 years, we're going to be like 20 megawatt is like, no, nobody gives a damn. 20 megawatt is like 20 megawatt. So area is under our control. That's why we keep making it bigger. Now, there is another aspect of it. If you make it huge, you also reduce the number of parts, meaning what you're getting paid for. You're getting paid for power, how many megawatts you are selling. So if you are selling 10 megawatts, it's far more cost effective to have one turbine rather than 10 turbines. So if you have 10 turbines, again, you have 10 rods, pylons, gearbox, motors, basically power control systems, sensors, everything. You have 10 of it. But if you have 1 mega, big one, again, everything part count goes down, fundamentally speaking. So that's why it's, from an economics point of view, this is the easiest way to reduce cost of unit of electricity. It's like, make the thing damn big. So instead of having hundreds of turbine, you have few hundred turbine. So instead of like, let's say a wind farm, in old design would have required, like the turbines that we have right now, it's so ginormous. Like back in the day, if you have talked to anyone, it's like, bro, we're gonna give you a wind farm that is 2 gigawatt. Then they would have laughed out of you. It's like, bro, we have to put so many. Now it's like, we have it. I'm not even joking, like we have it. It's old news now. It's like, nobody even cares about it. So few turbines. So that's the whole aspect of it. It helps out economically. So we want to make it as big as possible. So, and the key factor, the core focus of it is the dollar per unit of electricity. Now, there are two factors in this also. You have to understand, if you are an energy surplus country, meaning let's say you have your own oil and gas system, or you have geothermal, where you do not have to worry about anything, you are very price insensitive. Basically, you're like, bro, I'm not gonna buy that. You're like, bro, I have a good supply. I don't have to buy it. But let's say you are in Finland and you were like, I'm running a good oil and gas system, but Russia goes, lol, they turn it off. What the hell you do? At that point in time, you are in danger. At that point in time, you will be willing to pay whatever the hell somebody is charging. So at that point in time, even the fact that these puppies produce power a bit more expensive, people will just say, shut up, take my money. Because again, grid has a certain level of requirement. So at surplus point, it's like, bro, shut down power, we're not going to buy it. At point of desperation, it's like, bro, how much you want? Like, just shut up, here's a blank check, pay. So you have to understand, that's why from a country's point of view, the equation is a bit different. It's not just like, oh, this many megawatt, even though many times people are like, dude, why you are buying electricity that is so expensive? They're buying it, that expensive electricity, because that's under their control. And that gives them the leverage that other countries cannot just like, oh, I'm going to turn off your gas, or I'm going to turn off your coal, which Australia did to China. So you have to understand, like, there is a complex level of economics going on. So supply also matters here. So like, if you have surplus, then again, you are very price sensitive. Where it's like, I'm not gonna give a damn unless it's like damn precisely cheaper than what I already have. But if you are in like majority of humanity, it's like, bro, unless you are like in OPEC nations or Russia, most places have to buy electricity or energy, quote unquote. So they are like, shut up and take my money. Then we come to the base aspect. It's like, we know the turbine, we have been building it, we have it. It's a control C, control V technology, we got this. So what we don't got is the new part, the floating part, the base, basically the floating base. Now, thankfully, because of our 1 century of R&D that we poured into oil and gas industry, we have these puppies. Now these puppies have this tendency that they do not make sense to us, because again, they are not surrounded by anything. Like even if we watch documentaries about them, it's like inherently does not convey that these things are size of a hotels. Some are even huge, size of a hospital. Just floating is just like, eh. And they go through the most brutal natural environment and they don't even give a damn. It's like, oh, there is so much tsunami. It's like helicopters can't go there. You will think like, oh, how badly people are hurt there. It's like people are like, ah man, it's so noisy. Like they do complain about noise, but that's the whole point. It's like nobody even gives a damn. Like these are so robust, and you may be like, okay, I'm saying that now. What about in 10 years from now? Again, we have 1 century of data, so we have learned how to fight the sea. These puppies have proven track record. The only time these go boom is when humans make it go boom, or like basically the black gold that we are extracting sometimes get a bit excited, then it goes boom. Other than that, nature cannot make these go boom. Like it's a damn miracle that we have that sort of robust engineering where it's like, I'm gonna build this, I'm gonna put this in salty water, and salty water cannot do. It's like, you shall not crack, and this puppy does not crack. So it's a miracle of engineering that we have this, and we do not even give a damn about it. It's like, an engineer built this, and we like, eh. So we have that technology. It's like, we got it, don't worry about it. Then question is, how do we make it cheap? Like these things are awesome, but they are expensive, like super duper hyper expensive. Turbine itself is expensive, so you really do not want the base on it, basically the floating base or floating island, whatever you want to call it, also be expensive. So that's the issue, and we want to make it low cost while not compromising. We cannot compromise it. Basically these things have proven that we can build something that can last 30 years, 40 years, 45 years, 50 years. We want that for our turbines also. So even if we have a base there, turbine gets old or damaged or something like that, we can just like swap the turbine. We would like something like that. That's what we want, and keeping the cost down. Can it be done? Is there physics, engineering, economics there? Yes, it can be. It's just a matter of reconfiguring things. So how do we achieve that? How do we have a floating thing that's just like, I don't give a damn about the ocean waves? Well, you go into this. So this is basically center of buoyancy and center of gravity. These are the two vectors you control. So all you have to do is make sure your center of gravity is below center of buoyancy. Now that buoyancy part, if wave tries to tilt you, this creates a counter force by that very action. So basically, so you inherently become self-stabilizing, meaning these structures are passively stable, meaning you do nothing to it, no electronics, no control, and it's like, bro, I got this. That's why these things are so robust. It's like, bro, I got this. And the more we build it, the more better we get. And you can even have anchors on them, of course, because you have to understand there would be high voltage power line. These also need anchor, not for the structure, but for the drilling that they are doing. So same goes here also. You're gonna need a high voltage DC line going downwards. So you want to put as little stress on those cables as possible. So for that reason, you would have anchors that will give you extra level of stability. Now, how do you achieve this aspect, like center of buoyancy, center of gravity? That's a complete equation of mathematics and cost, because there are some options where you can have like very small steel structure, but you have to put a lot of ballast. Now, let's say you live in a country where you have cheap lead, just put it. You put lead in ballast, so a small area, boom, done, go home. Some areas like, bro, no. Then you have to put concrete there. Some places like, bro, no. You have to put iron there. It's up to you. So, and how big the structure you make, that depends on the sea area, what kind of currents you are expecting, what kind of oomph you are expecting nature to throw at it, because these things are made from a catalog nowadays. It's like, you tell them, it's like, this is the location, this is the gas well, they're like, okay, wait a minute, here they will flip a catalog, and it's like, sir, this is what you want. So we have the technology, basically, that's what I'm trying to say. We have the base technology and time-tested reality also, where it's like, no, we know this will work, we know. And if it did not work, let's say you built something and it fall apart, you knew something else went wrong, meaning maybe welding was wrong, or something else could happen. Like, again, we are humans, not gods. So something bad could happen, but we know the science, technology, engineering, those parts are sorted. We got this. We got this. So what about the cons of this sort of magical technology? Well, we need a lot more material, meaning when you are talking about offshore wind farm, right now, I don't even know why they call it offshore, because while it looks like in the sea, it's inherently goes in their base, is just standing on water. Basically, it's like when you go to a shallow river and your foot is touching the ground, it's exactly the same for them. So what happens is, like, there's a boat, special boat which has 4 legs. It goes there, janks all his 4 bolted down, becomes stable, then pulls out another robotic arm, puts it down the pile, hammers that piles into the ground, then brings another rod, basically the pole, and then yoinks that pole on top of basically the anchored part, pylon part. Then it puts a hub there, puts blade one by one, voila. So inherently, it's just a land-based structure. It's just like there is a bit of water on top. How deep these puppies can go? Generally, around 70 meters is the part where people are like, bro, you can go there. It's not like physics stopping you. Like we have bridges that have pylons that go even deeper than that. It's just that cost-wise, it does not make sense. So 50 to 70 is like gray area. So we need a lot more base. Like if you take the material cost of this, basically how much steel, concrete, and these big puppies you are consuming, let's say that comes at X. This puppy could come at 10X. Basically, they were talking about like how a normal offshore wind farm is like 60 ton base wise, and this one could be 2000 ton. I was like, what the hell? Again, making sure the center of gravity is below center of buoyancy. That puppy requires some weight. So remove engineering cost, remove the manufacturing cost. At the end of the day, material cost is also a serious thing, meaning if you are consuming 10 tons of steel versus 60 tons of steel, 60 ton would be more expensive. So that's inherently limiting based on the design. Then we come to another aspect, power rails, because these things are basically they are standing. So their power cables are very relaxed. They're like, that's it. There's just one fixed cable. But when you're talking about floating, the cables are also floating. So meaning they have to be designed to withstand fatigue, and they have to design, withstand fatigue for decades. Because again, even a little bit of flexing day after day, year after year, decade after decade will damage anything. So it does require a serious amount of engineering on that puppy. So it's very expensive. And then unit of power, basically the energy that is selling, it is more expensive, flat out. Like there is no discussion here as of now. It will require some elbow grease to bring it down, but as of now it's expensive. Now, when I'm talking about oil rigs, those are mature technology, meaning I told you there is a catalog. You can just open up, it's like, bro, I want this sort of catalog for this. This is my location. They're like, this is what you need to do. In wind turbine, we do not have that. There are many companies that are building up their own design. Some have single floating pylons, some have a triangle pyramid sort of system, some have tension wire. Basically, there is a floating structure that is anchored to the seabed, and that's how it's stable, because like literally the lines is on the tension, but that creates an issue. How long can you expect those cable to not stretch, corrode, or get damaged? Like be mindful, you are expecting something to be there for 30, 40 years. So that's a serious issue. Like we do not have an absolute configuration. Like this is the configuration, this is what we're gonna do. Like we have absolute configuration about wind turbines. All wind turbines looks alike. Why? We've narrowed down the engineering. Basically, this is the best compromise we can have with the most oomph we can get out of it. In terms of the floating base, there is no fixed design. As of now that I found is like, this is it, this is what future will be. Right now we are in the early trial stage, meaning people working in China, they will develop their own design. People working in Europe, they will develop on their design. People working in USA will develop their own design. So right now there is no single final design winner. As of now, I do expect it to come out eventually in next 10 to 20 years. An effect on marine life is unknown. Some people say it's very good because once you have this sort of floating structure, it becomes a sort of coral reef, and it does create, like flat out, it does create an ecosystem around it. But sometimes we'll say these are hostile ecosystems. Sometimes we'll say it's temporary, unknown. Basically, I do not have enough data about that. And birds, again, that's also another issue. What happens to them? There are a lot of engineering, good engineering going into them to make sure that they are far more basically obstructing to birds, where birds will not just try to fly through them. It's like birds will be like, nope. So that's what we are trying to do. Make sure the birds can go nope around it. So there are some serious consequences here also. But what about the pros? Pros is the cost. The fact that we are saying that it's expensive is not a fixed issue for anyone. Basically, every country and every person who's pouring their money into this, they are not worried about cost at all. The reason for this cost will be solved. It's just a matter of scale, meaning how the heck we humans went to from a point where it's like solar panels was so expensive it can only be used for satellites, to people are putting that in their home. Mass production. How the heck offshore wind farm? Think about it. Like we have turbines that are 15 megawatts docked into the sea, surviving for 10 years, and we do not even give a damn about it. Why? Mass production. Once you reach that mass production, cost goes down, engineering gets locked down. This is how we build the tools. I was talking about that boat and all that, and all the HVDC links. All these things are already there. We have all the data that we need to. Once we do, like instead of companies ordering, let's say 5 pieces, 10 pieces, we started to order like, let's say 100 pieces, price will go down. It's a known problem. Like not even a problem. It's more of like, we are just waiting for bulk order at this point in time. And what about the technology? Again, all technologies are time tested. So turbines, we have turbines that have been running for 20 years. We have turbines that are 10 megawatt or up. We have a floating system that have been floating for, well, almost a century. So we have lot of data, and all core components. HVDC link, how the heck we gonna do that? It's like, bro, it's a World War II technology. Back in the days we had this. We still using it. It's a known thing, solid thing, we got it. So all things point to a point where it's like once we build the factories, it will go down in cost. Now there is another aspect of it. Like this is a floating turbine that they were building. Now, when I was talking about land-based system, you have to have a special boat. That special boat has to go into a special place where you're gonna do the piling thing, and then it has to do everything. It's very expensive. This puppy, you built it on land and you just float it there. You built it on shore. Now, what does that mean? Like from a cost point of view, putting people in a boat and asking them to go deep sea and working there, their hourly rate goes exponentially up. Versus asking someone is like, here's a coastal area, that's where you have to work. It's almost land-based price. So fundamentally from a manufacturing cost, it will go down exponentially. That's why I said cost is not an issue. Every engineer who is looking at it is like, cost is not an issue. The moment we start to get that big orders, the moment these sort of factories start to become like, okay, this is our factory, this is how we're gonna build it, the end. Nobody would even talk about cost. It's sorted. And again, given the fact that you can just build it and keep floating them out, never being affected by the weather or deep sea ocean currents and all that jazz, that's awesome. And it can provide 24/7 power. We know, we have enough satellite data, we have enough long-term data that we know. If you put a turbine there, that puppy will have on time of almost 100%. Now, the reason we do not have 100% on time at this point in time is because of power curtailment. It's like many times we have to shut them down, maintenance, other things, like sometimes the wind speed could be too high, whereas like letting them spin could be unnatural amount of strain on the structure. But we know we can extract power. And as we do it more and more, that back in the day it was barely 30%. Now it's like 40%. We are reaching a point where some wind farms are reaching 50% on time. So we can truly, brick by brick, day by day, we reach a point where it's like, it's there, man. Don't worry about it. It's just there, 100% on time. Now, will it have ups and downs? Absolutely. Now, here's the more interesting part about that. It's predictable. We are so good with weather data that weather data in Germany, when they're like looking at a wind farm, it's like, this will be the output in next 5 days. It matches. So it is 24/7 and it's abundant, meaning if you really start to mass produce these things, no country will ever run out of power. Flat out. Like flat out. It's like, oh, it has this much power. No, no, no. Humans cannot consume that kind of power, and it's solar energy with extra steps. So do not worry about it. And all data from all countries, all research paper, surplus power is there. Like we do not have to worry too much about it. And one another aspect is, environmentalists can get into the way of it's like, oh, you're putting wind turbines is going to destroy birds. I'm like, dude, if we do not do this, we destroy the whole ecosystem. So choice is go from 1G to 2G to 3G to 4G to 5G. You do not jump from 1G to 5G. Maybe in future we'll have a technology that has zero impact on the environment. Right now we are not there. So we have to do the best we can do at this point in time. So we can survive for tomorrow. So we can go from, oh, we have built 3G, not really great. Oh, now we have built 4G, better. Then we like 5G, even better. Actually 4G is the best technology, but that's besides the point. So the fact that these things are out of sight, meaning people cannot see it. Once you put it below basically the event horizon, basically once you see the horizon, you have to, again, height of these things do make it, you have to send it much further off because people do not like to see it. So once you can make sure that it's far off, nobody has to worry about it. Out of sight, out of mind, nobody has to worry about it. And China is pouring money into this. Why? Again, even China does not want to be reliant on Russia. It's like, Russia, bro, come on, man, give us cheap oil and gas. Or, hey, bro, Australia, man, come on, give us coal. You do not want that. No country wants that. India does not want it. USA does not want it. European Union does not want it. So which are the two countries that are pouring ecosystem that are pouring money into it? China and EU. China has already claimed that they have built the biggest one. And I looked at the Trilong structure. This structure, they were so smart. They were like, hey, we have tubes, right? Giant tubes. Those are expensive. What if we just had a flat welding? And I was like, damn, nobody thought about this. It's like we have laser cutters that can cut, like there's CNC gantry at that point in time. They can cut 2-inch thick steels without any issue. You just put there, cut it out, weld it, go home, done. And I'm like, damn. So Chinese people, mass production. That's why I'm saying cost is not an issue. It's just like getting all things sorted. So they are working on it. European Union is like pouring money like there is not tomorrow, because again, Putin actually gave them a very good bitch slap where they're like, no, bro, we really need energy independence right now. So money is pouring in like there is no tomorrow. And again, it's important from a national security also point of view, where how reliable your country is directly proportional to how reliable the cost is. How reliable the cost is directly proportional to how reliable the power is. So if you have good power, good stability, everything works smoothly. That's why we have to invest into these things. I have linked lots of video down below. Please do check them out. And this was my presentation on floating wind turbines. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.